Metal powder technology will never reach its limits. It will evolve as long as innovation thrives in the minds of engineers. Truly, it is only constrained by the designer's imagination. The journey to unlock cutting-edge solutions demands collaboration among visionaries, fabricators, and customers alike. Each partner plays a crucial role in transforming ideas into reality. Powder producers tirelessly enhance material performance, while equipment manufacturers push the boundaries of technology, ensuring that every new challenge is met with ingenuity. Together, they pave the way for advancements that redefine what is possible in the realm of powder metallurgy, making it a continually evolving field of potential. Ladies and gentlemen, we are excited to unveil a selection of groundbreaking innovations that have earned accolades in the 2025 Powder Metallurgy Design Excellence Awards, proudly sponsored by the Metal Powder Industries Federation. Let's start with the awards of distinction. Nichols Portland Incorporated, Ridgeway Division, received an award of distinction in the automotive engine category for conventional PM components for a slanted sensor boss. This slanted sensor boss is used in automotive emission control systems, manufactured from 409L or 434LCB for optimal weldability and corrosion resistance, with the latter reserved for premium applications. The design features a shelf die and a 3D printed bolt-on angled die extension to ensure even powder fill across the lopsided flange. Achieving a compacting pressure of 700 megapascal is crucial for the desired green density, as the part shrinks 8 to 9% during sintering. The bosses are welded for quick assembly and long-term reliability, passing a 100% leak test with a minimum sinter density of 7.2 grams per cubic centimeter, significantly reducing material waste compared to traditional machining methods. GKN Sinter Metals received an award of distinction in the automotive transmission category for conventional PM components for an oil pump assembly. This innovative oil pump assembly is used in a cost-effective dual-clutch transmission, marking the first full integration of an electric motor in a hybrid electric vehicle. The assembly features upper and lower covers, a gear-rotor set, a pump core frame, and a copper steel bushing, all crafted with high-density materials. The redesign from die-cast aluminum to PM components enhances pump performance, minimizes NVH scattering, and lowers costs. Making and assembling all components at the same location avoids the use of disposable packaging and reduces shipping costs, leading to reduced CO2 emissions. Burgess Norton Manufacturing Company received an award of distinction in the automotive transmission category for conventional PM components for a reaction block and cam plate. This reaction block and cam plate is used in a mechanical locking rear differential. The reaction block is compacted using a dual cavity die with dual upper and 3 lower punches, employing ejector pins to prevent sticking. Made from FL4405, it reaches a density of 6.9 grams per cubic centimeter and is heat treated to 35 to 50 HRC hardness for durability. The cam plate, manufactured from F0008, is compacted to 6.8 grams per cubic centimeter, copper infiltrated for strength, and features precision inspections to ensure reliable locking action and performance. Metco Industries Incorporated received an award of distinction in the automotive chassis category for conventional PM components for a damping piston. This damping piston is used in automotive shock absorber systems. The compaction process involves multiple independent press functions to achieve precise dimensions and mass. Special handling techniques are employed throughout production, with secondary machining performed using a special lathe for intricate features and tolerances. A dedicated deburring operation ensures a surface finish roughness average of 125 to 250. Copper steel FC0208-50 was selected for this damping piston that is designed for smooth, stable vehicle operation with controlled fluid flow, demonstrating the advantages of high-precision PM compacting for complex shapes that alternative methods cannot efficiently produce. Phoenix Sintered Metals LLC and their customer ZF Safety Systems received an award of distinction in the Automotive Chassis category for conventional PM components for an anti-rotational sleeve. This anti-rotational sleeve is used in electronic braking applications. Density control is crucial, with the part compacted on a CNC press to ensure integrity, especially at the thin flange leg junction. Made from FLC 4805, the sleeve achieves a minimum density of 6.8 grams per cubic centimeter and is sinter hardened to a Vickers micro indentation hardness of 250 to 400. Custom designed support plates minimize distortion during sintering, ensuring tight tolerances. This innovative sleeve enhances the drive-by-wire brake system introduced in 2021, significantly improving vehicle safety over traditional vacuum-boosted systems. Indo-MIM Limited received an award of distinction in the Automotive Chassis category for MIM components for an ASV top plate. This complex ASV top plate is used in active suspension system vehicle assemblies. The circular part features 30 narrow slots and 5 rib-like structures with a wall thickness of just 0.3 millimeters. The multi-cavity tool molds the parts, with the injection point strategically located at the center to ensure even material flow. Supported by hot runners and optimized cooling systems, the parts achieve a density of 7.8 grams per cubic centimeter using MIM 4605 and are heat treated to 42 to 48 HRC hardness. MIM processing allows for a 40% cost reduction while efficiently producing over 120,000 parts annually. Hangzhou Sino-MIM Technology Company Limited received an award of distinction in the Electronic Electrical Components category for MIM components for an aluminum nitride heatsink. This aluminum nitride heatsink is a brittle part that must avoid edge chipping, with strict requirements for flatness and parallelism of less than 0.03 millimeters, and surface roughness average roughness between 0.3 to 0.8 micrometers. The heatsink has a density of over 3.32 grams per cubic centimeter, a linear thermal expansion coefficient of 3.6 to 4.5 micrometers per meter Celsius, and thermal conductivity exceeding 170 watts per meter Kelvin. Used in silicon photonics optical modules for communication, it effectively dissipates heat while overcoming defects associated with previous CNC machining methods. Hangzhou Sino-MIM Technology Company Limited received an award of distinction in the Electronic Electrical Components category for MIM components for a middle plate. This middle plate is used in mobile phone folding screen hinges, measuring roughly 160 millimeters long, 7 millimeters wide, and 0.8 millimeters thick, with the thinnest section at just 0.3 millimeters. This part connects various mechanical devices and is crucial for the screen's rotation. A high fluidity feedstock is utilized, with hot runner molds and precision equipment ensuring dimensional accuracy of 0.005 to 0.01 millimeters. Made from MIM 17 4pH stainless steel, it requires a minimum density of 7.8 grams per cubic centimeter and a Vickers hardness of 520 to 580 and minimum 6% elongation after heat treatment. Nichols Portland Incorporated Metal Injection Molding and Metal Additive Manufacturing Division and customer Page Musical Products received an award of distinction in the Hand Tools Recreation category for metal AM components for a bar and yoke banjo capo assembly. This bar and yoke banjo capo assembly temporarily shortens banjo strings, altering the pitch and key of open position chords. Made from 17.4pH stainless steel, the components maintain a relative density of 99.5% and hardness of 38 HRC. Hole tolerances are held to less than 0.038 millimeters, requiring minimal secondary processing. The metal AM process offers a 50% cost reduction, design flexibility, and lower environmental impact compared to traditional manufacturing methods. MPP received an award of distinction in the lawn and garden off-highway category for conventional PM components for a clutch shoe. This clutch shoe is part of a centrifugal clutch used in a chainsaw assembly. The flange's offset features pose challenges in compaction, including potential cracks and density issues. These were resolved with an innovative compaction toolset featuring 2 upper punches, 4 lower punches, 2 core pins, and a compensated fill die with a powder sweep. The FL4905 clutch shoe achieves a minimum density of 6.9 grams per cubic centimeter and undergoes chamfering and carbonitriding for a vigorous micro-indentation hardness of 900, essential for strength and wear. Conventional PM was selected for its effectiveness in producing complex geometries at high volumes. Hangzhou Sino MIM Technology Company Limited received an award of distinction in the medical dental category for MIM components for an endoscopic anvil. This endoscopic anvil is a component of a stapler used in thoracic and abdominal surgeries for tissue resection and anastomosis. The stapler uses titanium staples to cut off or anastomose tissues. It is easy to operate, streamlining operations and reducing surgery time. Special sintering supports were designed to maintain part dimensions and prevent deformation. Made from MIM 174pH stainless steel and nickel Teflon plated for biocompatibility, the parts achieve a minimum density of 7.6 grams per cubic centimeter, and tensile strength exceeds 1,000 megapascal. MIM processing reduced costs by 50% and enhanced material sustainability. Advanced Powder Products Incorporated received an award of distinction in the military firearms category for MIM components for a sear housing block. This sear housing block is used in pistol firearms. The development team addressed over 100 critical dimensions, most within plus or minus 0.025 millimeters. The design included numerous blind and through holes, requiring tight tolerances and maintaining integrity in thin walls to avoid subsurface defects. The molding process achieved a 4.96 CPK on the green mass, while delaying cooling and ejection time preserved wall integrity. Made from S7 tool steel with a minimum density of 7.5 grams per cubic centimeter, each part underwent CNC drilling and X-ray scanning was used to ensure quality. MIM was selected as CNC machining was cost prohibitive. Ladies and gentlemen, these are the winners of the awards of distinction in the 2024 PM Design Excellence Awards competition. Please join us in acknowledging their achievements as company representatives accept their awards.